For tens of thousands of years, humans survived in dirty environments, eating contaminated food and almost unaware of personal hygiene. In the last 100 years, however, we have developed a much more sanitary lifestyle, and this adjustment has not been entirely positive for our health. Despite modern drugs and surgery, the quality of our day-to-day health has deteriorated, with allergies and workdays lost to illness at an all-time high. The unsung hero of daily health is the innate immune system. It is constantly fighting off bacteria, microbes, viruses, pathogens, infection and disease using an army of killer cells that gobble up or destroy anything that has infected us and might make us ill. This army of cells includes macrophages, neutrophils and dendritic cells, as well as eosinophils, basophils and natural killer cells referred to as T cells. There are messenger cytokines and interleukins, and there is the complement system that uses a sequential activation of complement molecules to trigger a cascade of biochemicals which attacks targeted microbes. There are many others. There are literally billions of cells specializing in defending you from an equally prolific army of invaders on a minute-by-minute basis, and it has been this way for tens of thousands of years. And now they no longer have the tools they need to do their job properly. Disinfectants, antiseptics, soaps, detergents, bleaches, sell-by dates, vacuum packing, chlorinated water, air purification, sanitation, refrigeration, pasteurization, sterilization, refuge collection, and all the other modern tokens of civilization have protected us too well. And crucially, they have removed 1316 beta-glucans from the food chain. And without these, our innate immune system is degraded. Like an army or athlete, the immune system needs to be in training to be fit and effective. And like an army or athlete, it becomes ineffective when it isn't active. For example, the latest theories on the cause of allergies suggest that T0 cells only morph into T1 killer cells if there are present threats. If not, they become T2s, T3s, etc., which have a tendency to attack inappropriate targets. In an allergy such as hay fever, the immune system overreacts to dust or pollen in the lungs, and in an autoimmune disease like arthritis, the immune system attacks cartilage in your joints. There is mounting evidence that if the immune system was primed with beta-glucans and supplied with the other nutrients it needs, such as vitamin D, it wouldn't be so prone to attacking the wrong targets. What's the solution? We need to fill the nutrition gap, and in particular replace the beta-glucans that have been removed from the diet. These act as immunomodulators, a trainer for our immune system that keeps it on its toes and pointing in the right direction. One of the missing ingredients in our diet is the fungus yeast. It was ever present on fruit, bread and other foods in an age before fungicides and refrigeration. Another major source was the yeast in brewed and baked foods. This has been removed by pasteurization, filtration and alternative production methods. Yeast contains a long-chain carbohydrate molecule called beta-glucan 1316. Glucans are macromolecules made from the carbohydrate glucose. Glucans have numerous naturally occurring forms and occur in microorganisms and some plants and fungi. Glucans differ widely in their structure, properties and effect. Some are digested. Others, such as the 1316 beta-D-glucans, are immune modulators. When absorbed into the body, they harmlessly mimic a fungal intrusion, which in turn stimulates an immune response. Not all beta-glucans are equal. Beta-glucans are only immune modulators if they carry side chain branches off the beta-1,3 chain at the 1,6 position. Branches which, like the main chain, are made up of glucose molecules. Glucans with these side branches are called 1316 beta-D-glucans or beta-glucan 1316. Only these beta-glucans are able to support the immune system. The best way to enhance your immune system is to take beta-glucan 1316 orally, and best in a capsule to ensure maximum bioavailability. This is important to ensure that when you swallow a beta-glucan capsule, it dissolves in the stomach, releasing the beta-glucan so that it can be transported into the small intestines, for absorption by special areas, which are known as Peyer's patches. Peyer's patches are covered by an epithelium that contains specialized cells called microfold cells. These M cells pick up and transport the beta-glucan particles into the body and present them to innate immune cells called macrophages. The macrophages then transport the beta-glucan throughout the body to immune organs such as the thymus, liver, lymph nodes and spleen via the lymphatic system. While in the immune organs, the macrophages digest the beta-glucan into smaller fragments and release these over a period of several days. These glucan fragments bind to neutrophils, natural killer cells and other immune cells via the complement receptor, priming them for activity. When a pathogen enters the body, antibody and complement bind to it. This complex attracts macrophages and neutrophils which try to kill the pathogen. If the immune cells are already primed with beta-glucans, they reach the pathogens more quickly and react to them more vigorously. Glucans assist and enhance processes known as chemotaxis and cytotoxicity, effectively making pathogens much easier to find and kill. With the beta-glucan already present, the primed immune cells simply need to bind to a bacterial, viral or other pathogen to activate this enhanced killing ability. There is also evidence that beta-glucan can help neutrophils enhance the effectiveness of monoclonal antibody anti-cancer drugs. So now more than ever, you need to bridge the nutrition gap by taking beta-glucan 1316 regularly to protect your health, and if you are ill, then it also bolsters